Hi, and welcome to another video on object-oriented programming in C#, with me, Marinas Toman. Okay, so in this video we're going to talk about the unified modeling language and class diagrams in particular. So the unified modeling language, or just for short UML, is a general purpose visual modeling language that is intended to provide a standard way to visualize the design of a system. UML provides a standard notation for many types of diagrams, which can be roughly divided into three main groups: behavior diagrams, interaction diagrams, and structure diagrams. So the structure diagrams are basically what we want to look at. So if we go down and see kind of what types of diagrams we have. So the broad types here are behavior and structure, and you can see a class diagram would be classed as a structure diagram, and for example the use case diagram would be a behavior diagram or a state machine diagram. So these are all different, or sequence diagram. These are different diagrams that you can document the behavior of a system, but what we want to do is document the structure of our system. So class diagram is really what we care about, in this kind of context. So you can see here, you have all of the different diagram types, and if we go to the class diagram, so in a class diagram in UML is a type of static structure diagram that describes the structure of a system by showing the system's classes, their attributes, their operations or methods, and then the relationship among the objects, so among the different classes. So you can come over here, Wikipedia is always a good source when you're first learning about something. They go through quite comprehensive descriptions and basically tell you everything you need to know. So in this video we're just going to go through a short tutorial, basically looking at what's relevant to us when we're using class diagrams. So the class diagram is a graphical notation used to construct and visualize object-oriented systems. Class diagram is UML. In the UML language is a type of static structure diagram that describes the structure of a system by showing its classes, their attributes, operations, and the relationships. So for this video, this part of the video, we're not going to look at relationships. We'll look at that in a later video. So we should know, hopefully at this stage, what a class is. A class is just a blueprint for creating an object. Object and classes go hand in hand, and we can't talk about one without talking about the other, because an object is an instance of a class. So they're very much related. And the entire point of object-oriented design is not about objects, it's about classes. And because we use classes to create objects, this is why it's so important. So a class describes what an object will be, but it isn't the object itself. So kind of, as you can see in this example here, a base class would be a dog, and then the actual instance of it would be, what are the details of that dog. So in fact, classes describe the type of objects, while objects are usable instances of classes. Each object was built from the same set of blueprints and therefore contains the same components, so the same properties and methods, the same state and behavior. And the standard meaning is that an object is an instance of a class, and objects have states and behaviors. So that's what we mean by, the properties will have certain states and the methods describe your behaviors. So you could say, in the base class, our properties might be color, eye color, height, length, weight. So these are things that describe the object, the object that we're going to create. And then the methods or the properties, the behaviors might be to sit, lay down, shake, come. And then whenever we have an instance of this class dog, then what we're doing is we're making it concrete. We're creating a concrete instance that gives values to these properties. So in this example, it might be yellow dog with brown eyes, and certain height, length, and weight. And then that means that we can, assign this object, this dog, Bobby, these behaviors or these methods. So hopefully, class as an object should start to understand what the differences are. So a class is just the kind of outline, or describing what an object can be, and then the object is an actual instance of a class. So UML class notation, class diagram notation. So a class represents a concept which encapsulates state or attributes and behavior or operations. So we'll call attributes or properties, variables, fields. These are all interchangeable. These are all the same thing. Operations, functions, methods, behavior. This is that's all the same kind of interoperable terms as well. So each attribute has a type, each operation has a signature, and the class name is the only mandatory information. So you can leave out, a class doesn't have to have methods or operations, or it doesn't have to have fields. These are optional, but the name of the class here, this is mandatory, okay, and this always goes at the top and usually centered as well. So you can see in these examples here we have a class without a signature. So this is where you don't your operations and your properties, you're not given the full signature basically. And then if you look at a class diagram with a signature, you can see not only the name of the property and the visibility, but the actual property type as well. And the same as this would usually be the return type. Okay, so the get length, this is taking no parameters and it's returning an int, or set length is taking parameters in and then it's returning void. So the thing about class diagrams and UML class notation is that we are trying to get as much information across as possible without the least amount of information, basically. So the class name is what appears at the top. Attributes are shown in the second partition, so this is always the order, and this is why we typically tell you to write your programs in this order. To start off with your class name, then you set up all of your fields or your properties, and then you have your methods after that. And this is generally the same. We would do it in the same order in a class diagram. So attributes map onto member variables, so data members in the code. So as you can see in this example here, we just have an attribute length, and then we have our getters and our setters, our methods to get the length and set the length. So you can see here, this is actually this would be a private field, because we'll see shortly, but whenever you see the minus, that little minus in front of length just means private. The plus means public. So operations are shown in the third partition. They are services the class provides. The return type of a method is shown after the colon at the end of the method signature, so here. And the return type of method parameters are shown after the colon following the parameter name. So you can see just the type of the parameter. So in this example here, my class name, that's the name of the class. This would have 3 attributes and 3 operations. And then as you can see here, these attributes have different visibilities, and then they have different types. Okay, so one of them is even of a type of class called circle. And then we have public and private, and then this is usually protected, is what the hash symbol is. So this is your protected attribute. So this operation 2 returns a float. This in out, we'll talk about that in a minute, or the in or the out words here. So sometimes you can, basically describe which direction is the parameter going. So each parameter in the operation may be denoted as in, out, or in, out, which specifies its direction with respect to the caller. So sometimes you want to say, is this parameter going in and out, or this one's just going in, or this one's coming back out again. So sometimes what we'll normally do is just by default we will kind of just leave them out. Most of the time, if your parameters are going in, we know that, and then we can just, as long as we know the return type, we won't bother with saying what parameters coming back. So that's pretty much it for, the class diagrams are pretty easy to understand, and the notation is not too much to really remember. Just your attribute, your class name comes first, then your attributes, and then your properties. And it's always a good idea to have your visibility, your attribute name or your method name, and then your return type or your attribute type. And then if it's a method as well, sometimes if this is all really down to yourself. Sometimes if you go into a company, they might have preferences. They might have their own standard way, their own standard notation. So they might require all of this. But just for yourself, it's good just to put in the information that you think that you need. So like we say, whenever we're documenting our classes, we want to basically give this is like documentation that we're drawing up here, but it's also us being able to design. We not only design our classes, but then we document. So we have an operation here that is public, returns a string, and it takes in a boolean. So as long as you can get across enough information for you and your teammates to understand, how is the class constructed, what are the attributes, what are the properties in there, and then what are the methods, and the class name as well, obviously. So for the moment, we will just be creating single classes, but as I say in later videos, you'll be able to see how classes can start to be related to each other. They can start to be connected within the system. Especially when we get into inheritance and polymorphism and things like that. Okay, so that's everything for the video. Thanks for watching.